Machine learning models routinely perform flawlessly in isolated, pristine sandboxes. Yet when those exact same models are forced into legacy corporate tech stacks, the infrastructure will often buckle under the integration weight. We can examine exactly how this happens by looking at Kindred Group, an online entertainment and gaming enterprise. They prepared to deploy a new AI hyper-personalization engine across 17 markets, right as the massive demand spike of the World Cup was approaching. This flowchart maps the required architecture, a clean journey from data source, through the CDP, into the AI engine. The AI needs demographic and preference data. During deployment, demographics passed the connector, but preference packets collided and dropped off, starving the AI of critical context. Treating data plumbing as a secondary IT task, rather than a mission-critical compliance layer, instantly turns a profitable AI model into a severe legal liability. Following standard engineering risk mitigation playbooks, the team scheduled the initial deployment for a Thursday. This is a deliberate tactic to ensure any immediate system breakages can be caught before the technical support blackout of the weekend. The core of this deployment was a hyper-personalization engine. It ingests real-time behavioral data to calculate and execute tailored promotional actions for millions of simultaneous users at scale. Upon launch, the baseline demographic data routed successfully. To the early monitoring systems, the architecture appeared perfectly stable. The gaming and telecom sectors operate under strict regulatory constraints. They are legally mandated to adhere instantly to user marketing opt-outs, as well as self-imposed gambling limitations. Because the preference flags dropped off in the pipeline, the hyper-personalization engine was operating completely blind to these limitations. It began calculating and queuing up targeted promotional offers for legally protected users who had explicitly opted out. Launching a non-compliant AI engine is an immediate regulatory breach. A failure at this layer threatens to wipe out the system's entire projected £6 million return on investment in a matter of hours. The discrepancy in the outgoing promotions was flagged in the live production environment late on Friday, right as the weekend began. This cross-section of the API connector shows the underlying technical reality the team discovered. The vendor-provided API was structurally incapable of processing real-time preference schema updates, rejecting the distinct shape of the preference payloads while allowing the demographics through. The operational escalation was immediate. Standard protocols were bypassed, spinning up an emergency bridge of 90 engineers. Triage isolated the absolute failure point. The in-house AI algorithms were sound. The breakage sat specifically on the third-party CDP's outbound integration layer. Executives made the immediate decision to halt the hyper-personalization campaign completely, ceasing all non-compliant promotional outputs. To protect the revenue stream, engineers executed a failover maneuver, rerouting all user traffic back to the legacy backup system. The business experienced zero downtime despite the AI architecture failure. Preserving regulatory compliance and base business continuity will always override the deployment of a new AI feature, regardless of its projected revenue. For the remainder of the crisis weekend, the engineering objective was clear: achieve the original £6 million ROI without relying on the malfunctioning third-party CDP. This required an aggressive architectural pivot. Engineers built a direct data pipeline routing completely around the CDP. Custom scripts pulled raw preference data directly from the sources. This direct feed resuscitated the AI system, providing the missing context to filter outputs legally. The stack stabilized, the campaign resumed, and the company safely realized their projected revenue uplift. In the post-mortem phase, the team presented the third-party CDP vendor with the exact architectural flaw residing within their own product. The client compelled the vendor's product engineering leadership to build a net new, real-time connector specifically calibrated to support this modern AI stack. When managing decoupled enterprise marketing stacks, engineers must possess the capability to architect around vendor limitations, rather than waiting for external patches to save their systems. The Kindred crisis proves that while the AI logic itself is sound, the real engineering hurdle is the integration layer. But we are also entering an era where the cost of generating that initial logic is plunging toward zero. Large language models allow single engineers to output highly complex API-driven logic in hours. We are moving toward the zero-code generative application. This split-screen juxtaposition shows the contrast. On the left, an AI pricing engine logic built from scratch in roughly 60 hours using Claude 3 Opus. On the right, the rigid, heavily regulated enterprise pipeline required to actually run it. This creates a strategic dilemma for technical leadership. If an internal engineer can build the application logic practically for free, why should an enterprise continue paying millions for vendor platforms? The answer lies in the compounding tax of in-house development. Every internal build requires a team to maintain fragile spaghetti code, manually update breaking API connectors, and absorb 100% of the legal liability when guardrails fail. Technical leadership is now a choice between owning an ever-growing mountain of maintenance debt or paying a premium to transfer that operational risk to a vendor. When an enterprise invests in modern AI-first vendor platforms or managed workflow tools, they are purchasing risk mitigation. This matrix chart plots time against maintenance cost and risk. A vendor platform buys automatic regulatory updates and API maintenance, keeping the risk curve flat. Without it, third-party schema updates cause disruptive engineering sprints just to prevent a system crash. This reality redefines the core function of the modern enterprise solutions architect. Their primary value is no longer writing the machine learning model. Their mandate is architecting the resilient integration layers that ensure the model survives contact with real-world enterprise constraints. Technical execution is rapidly becoming commoditized by AI. Architectural risk mitigation is now the irreplaceable premium skill.